Hey guys, it's Anish, and today you're going to be learning how with no setup, no pre-installed downloads, whatever, and with just 6 minutes, you can make your very own TensorFlow Sign-Language Alphabet AI Classifier. All you really need is a Google account, basic Python knowledge, basic deep learning knowledge, and if you don't have that, I'll link some videos in the description to see later, but make sure you watch this video first so you know what to look forward in those videos. And all the code for this project will be linked in the description in a GitHub repo that you can just click, and I'll have a link to my Colab account and a little more details that you can use. So I just want to kind of introduce the AI algorithm, the main basis of what we're going to be doing. And it's called Convolutional Neural Networks. So you can see there's a data set of all those images. It's called the Sign-Language MNIST data set, and it has these the images and the signs for having the correspond with the alphabet of the sign language. And there's only 24 letters in sign language. So as you can see, first what we do is we make training images and testing images, and we normalize those images and transform them. So then you can see that they're pixels, and then there's this little thing that's sliding across that image, those pixels, and that's called a filter. And in filters, there's specific weights that can multiply those pixel values and create a convolutional block, and we can do pooling and ReLU and activation and all that cool stuff. And then we can feed it into a basic dense feed-forward neural network and get the probabilities for the 24 classes of letters in sign language. So that's a quick introduction to convolutional neural networks. And if you don't understand, don't worry. I'm going to make a video in this next week explaining in depth about the theory and the mathematics and how to build one from scratch. So make sure you subscribe so that you can see that video later on. And yeah, we'll be using Google Colab. The coolest thing about Google Colab is there's a free GPU, all for you to use. It's easy setup. There's cloud saving. You can download literally data sets on their server and use it. And it has a bunch of Python libraries. And not only that, it has our favorite deep learning library pre-installed, Tensorflow. And a lot of people you'll talk to who use Tensorflow, one, does not simply install Tensorflow locally. But the cool thing is Google Colab has all of that taken care for you, so you can just move on. So yeah, let's get right to it. Okay, so the first thing you want to do is search up Google Colab. And you want to have a Google account to do this. Click New Notebook. So then we want to change the runtime to our free GPU. So then we want to start importing all our import statements like NumPy, Pandas, Matplotlib, sklearn, IPython, all that good stuff. And as you can notice in Google Colab, there's that little play button thing. And that's how you run cells. And cells are instances of codes that you can run. You can add more cells, you can run it, and there's a lot of benefits on doing that. And also Google Colab can be used like a shell. So you can actually run like shell Unix commands on this. For example, if we want to download a data set, we can do wget, and then put in our data link. And I'll upload that in our GitHub repo so you can have instructions to do that. We want to unzip all the data that we also download as well. On the side, you can see that there's a file directory over there. And if we refresh that, we'll see the data is actually downloading into our file directory. So the next thing we want to do is cd into that, like a regular Unix shell command, and we can change the working directory by doing that. And as you can see, there's a folder called Sign-Language MNIST. So we want to cd that and change our working directory into Sign-Language MNIST. And we can do that, run that cell. Now we want to make our train and our test data. So we want to use Pandas to read our CSV file called sign-mnist-train.csv, and we can do the same thing for the test file. And while we're at it, let's visualize one of the cool things that are part of this data set. It's called American Sign Language 2 PNG. And if we look at it, it's a bunch of the sign language letters, and you can see how they correspond to the symbols. We can also explore our data, and you can see that there are 784 pixels. But if we look at the shape, there are 785 columns. We want to drop that. But first, let's set our labels. So we can take the label values, and then we can drop the label column. And by doing that, we can change our shape to 784. And we want our shape to be 784 because we want it 28 by 28 images, and 28 times 28 is 784. We can use the label binarizer class to transform our labels because it's categorical, like there's 24 letters, right? So we want to do that. Then we can set our images to the train.values. We want to transform our images to np.array. And we can do that by reshaping it. And we want to have I, which is every image, and we want to have 28 by 28. And we see we can do so for I in every image. We want to reshape it again. We want to actually flatten the array so they're going to have a one-dimensional array. Then we can also reshape it again. Then if you want to actually show the image, we can do matplotlib.imshow, and we want to reshape it so we can actually see it. So as you can see, that's our normalized image. So now we want to actually split our data into testing data and training data, and we can use sklearn's model selection library to do that. So we can do xtrain, xtest, ytrain, ytest, and we can use the split function. We want to put in our images, our labels, and we want to have 70% training, and we want to have 30% of our testing size, and we can make a random state. So once that's done, we want to normalize our data now, which means make the pixel intensity from 1 to 255. We want to do that for both the testing and the training. So now we can reshape that data into a 4-dimensional shape, so our convolutional neural network can actually take it in. We want to do the same thing for the xtest as well. Now we want to use Keras, finally the heart of the deep learning library, which is a part of TensorFlow. We want to import sequential, which is the model type. Then we want to import a couple layers like a dense, which is your basic feed-forward layer, a convolutional layer, max pooling, flatten, and dropout. So now we can finally start building our model. So we want to use a sequential model. We want to add a convolutional layer with 64 filters, which are 3x3. We want to use ReLU activation, which will normalize the pixel values. Then we want to pass in our input shape, which we know is a 28x28 image with a one-dimensional channel. We want to add a max pooling layer, and that'll set the maximum value out of every convolutional pooling layer. Then we can copy paste that 3 times and flatten it. Then we want to have a feed-forward network with 128 units, same ReLU activation. And then we want to actually drop out, and dropout will help us prevent overfitting. And overfitting is when our model memorizes the data instead of actually learning it. Then we want to make a 24 dense unit for the 24 classes and softmax to get the probability. And as you can see, we have to first compile our model. So we want to change our loss function to categorical cross entropy, and that's because we have multiple categories. We set our optimizer to Atom, which will help us change the learning rate adaptively. And we want to get accuracy results from our model training. And now we can finally train our model. So we use model.fit, pass in our training information. Our validation data is our testing data. We want to use 20 epochs, but I recommend changing it to more, how much ever you want. And you can see the model's actually training. So you'll see that the model's actually training. You'll see a loss function, you'll see accuracy. And as the epochs go on, you'll see that it gets better and better. And the epochs go pretty fast because we're on a GPU. And I would show you at the model training completely, but I want to save time. So while the model's training, let's prepare some of our test data. So we can get our test labels, and we want to change it to test labels. We want to get it from the test CSV instead. And again, we have to drop that label column. So we have 784 pixel columns. Then we want to prepare our test images. We want to fit our test labels with the label binarizer. Then, we want to change our test images like we did with the regular images earlier. And then once we do that, we can just use model.predict. But we want to see also if our model trained or not and what kind of accuracies we're reaching. So we want to pass in our model.predict. We want to put test images in. And if we run that, we can also get the accuracy that we get on the predictions. So actually, if you scroll up, I'm not going to scroll up right now, but the accuracy should be 99% on the test data, but the predictions are going to be probably a lot worse. Right, so it was around 78% on the test data, which is not that bad, but if you train for more epochs, you can do it. Now, if we actually want to visualize one of our test images, we can see that's a C. So let's see what our model will predict on that specific image. Let's just reshape it real quick, and we can see what we get. So yeah, you can see that there's a 1 1/3 value, and that corresponds with the C letter. So yeah, that's it. That was your quick, super fast way to learn deep learning, get hands-on on your first model, and yeah. So obviously the video was super fast. And you should definitely go back and replay some of the clips if you didn't understand something or slow it down, or even go look at the code that I linked in the GitHub to get a better understanding. But yeah, so in today's video, we kind of learned the basics of Google Colab. We did everything in around 6 minutes, including pre-processing a whole data set, training the model in those 6 minutes. Like, I didn't cut between the training or anything, and if you train it yourself, you'll see that the epochs are like 1 second or 2 seconds only to train, and you got to test it. So yeah, you got to train your own AI sign language classifier, and you could easily replace this model for different images, and you could use transfer learning. And I'll make a lot more videos about that later on. So make sure to drop a like and hit that subscribe button, and thank you. So see you again.